wanted to say a few words about signs of quantities when we're working with mirrors and when we're working with lenses, when we're working with the images of objects that are formed by mirrors and lenses. It's very important to get the signs right. And so we can look up the signs in the table to get the signs right. It's also helpful to understand where those signs come from, have an intuition about what's the correct sign, what's not the correct sign, and what those signs really physically mean. So I tried on this slide to make a bunch of bullet points related to the signs of object distances, image distances for mirrors and lens, focal lengths for mirrors and lens, and the meaning of magnification for the sign of the magnification for mirrors and lens. So let's start with mirrors, and let's just discuss the signs of the object and image distances. And firstly, just the meaning of the front and the back of a mirror. So for the case of the mirror, the front of the mirror is where both the incident rays and the refracted rays live. They're both living on the front of the mirror. The back of the mirror, that's the other side. There's no reflected rays or incident rays on the back of the mirror. So that's an important point about the mirror. A positive object distance means that the object is on the same side as the incident rays. So for the mirror, it will be on the front side of the mirror. And likewise, a positive image distance means it's on the same side as the reflected ray for the mirror. So a positive image distance is also on the front side of the mirror. So that's what positive image and objects distances mean. They're actually objects that are on the same side as the incident and reflected light rays themselves. If you have a negative object or image distance, that means it's on the other side of the mirror from where the incident and reflected rays live. So it would be on the back of the mirror. Okay, let's discuss now the meaning of positive, negative object image distances for the lens. And also, again, what do we mean by the front of the lens and the back of the lens? So the front of the lens is where the light originates from, and the back of the lens is where the light is going to. So the front of the lens is where the incident rays are, and the back of the lens is where the refracted rays are. And where those two types of rays live guides us in the meaning of positive or negative object image distances. So for the object distance, it's positive. If it's on the side where the incident rays actually are. So that's the front of the lens. For the image distance, if that's positive, it's actually on the side where the refracted rays live. So that's the back of the rear of the lens. So positive and negative object distances, image distances mean for a positive distance, whether it's the image distance or the object distance, means that you're on the side that ray exists, that incident ray or that refracted ray exists. A negative object distance, image distance means that object or image is on the opposite side to where the corresponding ray, the incident ray or the refracted ray lives. What about focal lengths? And what about focal lengths for both mirrors and for lenses? So focal lengths can be positive and focal lengths can be negative. And so what does that mean? Well, lenses that converge light bend the light towards the optical axis, and mirrors that converge light, bend the light towards the optical axis, they have a positive focal length. So that's what we mean by a positive focal length. It's a mirror or a lens that bends the light towards the optical axis. It can actually focus the light to a point. A mirror that has a negative focal length, or a lens that has a negative focal length, is a mirror or a lens that actually diverges the light, bends the light away from the optical axis. A mirror or a lens that diverges light cannot focus the light to a point. Now, there's some fundamental differences between converging lenses and mirrors and diverging lenses and mirrors that are related to the fact that one is bending the light towards the optical axis and can form a focus. The other one is bending the light away from the optical axis and can't form a focus. So for example, converging lenses or mirrors can form real images, and they will form real images as long as the object doesn't get too close to the lens, as long as it doesn't get closer than the focal length distance from the lens. On the other hand, diverging lenses, diverging mirrors, they cannot form real images. They always form virtual images. It's because a diverging lens, a diverging mirror, just bends the light away from the optical axis. So it cannot focus the light to a point to form a real image. And so that's the importance of the focal length, the sign of the focal length. It's really telling you whether you've got a diverging or a converging optical instrument. It's telling you whether your lens or your mirror is converging or diverging. Finally, just a brief comment down here. This is probably the most obvious one. The magnification. So the magnification of a lens, magnification of a mirror can be positive, it can be negative. The magnification just tells you whether the image is upright, so it would be positive if the image is upright, or whether the image is inverted. It would be negative if the image is inverted. Anyway, that's a brief run through the signs of the various quantities involved in mirrors and lenses and understanding the images of objects formed by mirrors and lenses. We talked about the image, the object distances and their signs, and how they're connected to the image or object's location with respect to where the incident or reflected or refracted rays actually live. And then we talked about the focal length and how that's connected to whether the mirror of the lens is diverging or converging. And then finally, we talked about the magnification and whether the image is actually upright or inverted.